Hey guys, welcome back to a research review. And this one is going to be a little bit tough for me because I could have chosen either side of this as a debate and could have presented ample evidence to prove a premise. What we're going to start with is sugar addiction even a thing? Like, is it real? And therein lies a controversy that I really can't say I was aware of until Dr. Brunacini this week presented a research brief for us in our Diet IQ posts. And essentially, it said that there is no chemical evidence, neurochemical evidence for the premise that sugar addiction is real. So the first thing we're going to talk about here in a few minutes is how do we even define addiction? Um, what are the controversies? And first of all, there is a ton of interest in this. If you just, for example, type in sugar addiction, you'll get a million Google hits instantly. There are entire books written about this. There are programs dedicated to helping people overcome sugar addiction. But this particular researcher said, not so fast. I think it's important that we look at this a little bit deeper. So let me get into who did this and why. The particular study that Kevin had brought to my attention this week is cited in this particular, I wouldn't call it a meta-analysis, more of just a position paper, but the plausibility of sugar addiction and its role in obesity eating disorder. So right off the bat, the plausibility, like what is this? Is it even a thing? This researcher, David Benton, comes from it as a psychology professor, but he really did all of his graduate work in biochemical pharmacology and how that relates to psychology, how it relates to behavior. So he teaches psychology, but he's really more of a biochemist, specifically a neurobiochemist, with 30 years of research and study and almost 350 publications at the time his information was out there. I think he's now retired. So this was, I think, let me see here. Was it 10 years ago? Actually, about 14 years ago. I did look, and there are even more bits of information now that he has contributed to. But let me get right into this particular position paper. And I do apologize. I have to move some things. If you guys chat, I may need you to kind of wave your hand or something here as I move them off at the side. I do have some pretty large snips because some of this is really incredibly important as we try to differentiate what this even is. So I'll try to be brief in how I read these and present these, but definitions are arbitrary, and the answer as to whether sugar is addictive may depend on how it's defined. For some, addiction is a pharmacological term characterized by a compulsion to consume, driven by cravings. Tolerance occurs so that over time, to achieve that same response, you need to increase the dose. So that's chemical addiction. And there's a dependence so that there are withdrawal effects if consumption does not occur, making it difficult to quit. However, the term addiction has evolved, leading some to designate this type of pharmacological definition as a physical dependence. And he goes on to say, put this back in here, that psychiatrists have started using dependence rather than addiction for this exact reason. The American Psychiatric Association criteria for clinical diagnosis of abuse and dependence is a maladaptive pattern of substance using or use leading to clinically significant impairment or distress as manifested by one or more of the following in a 12-month period. So chemical addiction is where he has a snag. And I think this is important because what I have heard in the past, and until this week, what I just assumed was knowledge that was accepted by everybody, is you have also probably heard these phrases that just like cocaine or like narcotics, sugar is addictive to the brain. We get the same response neurochemically to sugar as we do cocaine. I mean, all of these comparisons to narcotics have infiltrated, how we think of sugar, and to the degree that people are actually dependent or have some addictive affiliations, they now consider themselves addicts. They consider themselves sugar addicts. And as such, many people who struggle with this type of eating disruption, they feel powerless. They feel like, well, if this is an addiction, and maybe I'm not going to go to a 12-step program, I'm not going to go to AA, I'm not going to go get some kind of intervention, then I just have to avoid it completely. And just like somebody who may be an alcoholic, if I stumble, then it's all over. I'm off the wagon. And that's what this particular researcher has a problem with. And so he set out a large degree of his life's work to really look at those questions. So keep in mind that we're not talking about sugar being a difficult topic with nutrition and something evolutionarily important in how it manifests with hunger cues and with actual changes in our brain and our behavior. But is it truly an addiction? If so, what do we do? If not, what do we do? So here was one particular, he goes through different models. That this was the whole rat model. Remember, rats are about 94% DNA parallel to us. So we get an awful lot of good data here. And then you can move up to primate studies and human studies. Rats were deprived of food for 12 hours, then given 12 hours access to food, starting 4 hours into the dark phase. They could consume laboratory chow, and depending on the study, 10% solution of sucrose or 25% solution of sucrose. After being kept on the schedule for a month, the animals showed signs of addiction. During the first hour of access, there was a large intake of sugar, a phenomenon described as a binge. Withdrawal symptoms were displayed. In a similar manner to drugs of use, dopamine was released in the nucleus accumbens. Opioid antagonists produced withdrawal symptoms. Thus, there was a body of research that supported the suggestion that rats kept under this behavioral regime manifest physiological and behavioral changes consistent with an addiction to sugar. So this is where all of this started. This was the original premise that sugar could affect us like a narcotic. You can see these behaviors in the rats, when they were hungry and, given a chance to have a high sugar diet, they were drawn to that. And then they even had some of these addiction type behaviors. However, it appears that rats do not have a preference for sucrose consumption, as there is a preference for sucrose in sham feeding studies, where after passing through the mouth, it leaves the body, ensuring no post-ingestive effects occur. Dopamine is released from the nucleus accumbens with this procedure. The sweetness of the fruit juice is rewarding, as judged by the reward expectations related neuronal activity in the primate striatum, although it's produced by sugars other than sucrose. So there is also, this is another study, there's a preference for even artificial sweeteners. So you're not even getting the actual blood sugar. So that first model is where they ingest it, but then it never even goes into their body. So it's just the taste receptors. So the intermittent access of rats to a saccharin solution rather than sucrose has resulted in the same withdrawal symptoms. So they didn't even have the chemical, they didn't have the sugar in their body, but just when you took away the saccharin, the artificial sweetener, they had those same opiate type withdrawal symptoms. It appears that at least in part there is a response not to sucrose, but rather to the sweet taste. In contrast, Hopel suggested that his rat model of addiction, there is probably a greater response to sucrose, as there are specific receptors on the tongue and in the gut. But keep that in mind. So we're kind of creating a little summary chart here. The original models just looked at behavior. Well, they really seem to like this food. They seem to eat more of it when it's withheld. And yet then they said, well, they weren't really going more for the sucrose than just the normal chow. It was just food in general. And then they showed here with a couple different models that it was the taste, not necessarily the sugar. This gets pretty deep pretty quickly. So this conclusion is supported by studying the impact of opioid drugs, as a generalization has been known for many years that opioid agents enhance and opioid antagonists decrease feeding. So now we're going to get into some remedies pharmacologically to see if we can really elicit an opiate-like response. So the administration of morphine caused a short-term increase in food and at least initially an increase in fat intake at the expense of carbohydrate. The opioid antagonist, you guys may hear of these things, naloxone, the things like Narcan that we give opioid addicts to, bring them back to life. Decreased, let me see, it is known for many years, rats For rats, fat is more attractive than carbohydrates. These findings are consistent with the view that opioid mechanisms influence the intake of palatable foods. Such a suggestion is reported by the study of initial food preference, as there is a variability amongst rats in their preferences for carbohydrate and fat. So they distinguished fat preferring from carbohydrate preferring rats. They seemed to find some rats naturally liked sweeter foods, some rats liked more savory food. So it wasn't even completely species dependent. Uh, so now for just a second, let me summarize. We're looking at just behavior based on taste instead of what the chemical sucrose, the sugar, is actually doing to us. And now we're starting to see, even within a single species, it's not necessarily a binging episode or an addictive like behavior towards a sugar, but some, quote, people, meaning rats and then primates, including us, can display those tendencies toward different types of food. So it may not just be the sugar. Another thing that's very important if we're going to discern if sugar is actually an addictive substance. So that was kind of looking at the setup and the rat models. Now, eventually, they're going to get to some human models, but we're going to look at sugar and reward mechanisms. This is another type of way to discern addiction. Addictive drugs and palatable foods both release dopamine from the nucleus accumbens. That's one of the first reasons this became a topic of interest, was just the fact that when you consume, quote, sugar, but now we know it's the food you prefer, they have concluded that with humans as well, then you get this release of dopamine, which does create a pursuit response. Like, I want more. Wow, that was great. I want more. The nucleus accumbens has different populations of neurons that are activated by natural and drug reinforcement. So that's another thing that had not been looked at before. It's not just that dopamine is released, but where does that dopamine go and what does it do? This is a very specific question that starts to differentiate sugar from opiates. Although the food-induced release of dopamine is markedly inhibited by pre-exposure to visual and olfactory stimuli that have been conditioned to food, similar visual and olfactory stimuli that have been previously conditioned to drugs of abuse strongly potentiate the dopaminergic reaction. This comes up a little bit later in that it's an important bit of information that even food cueing without the food, just the smell of food or the visual sight of food can potentiate some change. Our dopamine starts to be released. That can be, but not necessarily tied to the entire opiate correlation. Central to the suggestion that sugar can be addictive is its interaction with reward mechanisms in the brain. Evolution could not anticipate the use of drugs of abuse, so it's inevitable that such substances stimulate existing neural circuitry. Frequently, it is suggested that drugs act at the sites that develop during evolution to react to natural rewards such as food, drink, and sex. The pathway that is stimulated by natural rewards associated with the median forebrain, the VTA, etc. What I wanted to point out here, the reason I put this one in here, is you have to look at this drug response to, as they said, the existing circuitry. So if we know the biological impulses of our brain stem and the autonomic nervous system are for those primal drives of reproduction, consumption, and sleep, then we have to start looking at how those are individually mediated, and why would the human brain equate one of these things with that? So, for example, that's how artificial sweeteners work. It's tricking your brain, your taste, into telling your hypothalamus that, wow, there's sugar, even though it's not sugar, so let's go. You have to be able to stimulate those to show that kind of compulsion. The administration of drugs that block the action of dopamine at the nucleus accumbens produce animals that will consume food but will not seek it out. So you're not necessarily getting that dopamine response. So if we block dopamine, you'll still eat, but you're not necessarily seeking out food. You don't necessarily need more. So you're basically just satisfying the biological need. Um, Barrage, this is the study that Kevin highlighted this week, considered the role played by the etiology of eating disorders by motivation, wanting, and hedonic liking, and commented that at present the data are still not entirely clear and sometimes contradictory. So this is another huge deviation in what we're going to call an addiction. There started this particular controversy when Barrage said, well, maybe it's really not addiction. There could be a difference between actual addiction and just cognitively wanting something or preferentially liking something. Hedonically, it gives me pleasure. It feels good to eat this food, and it could increase my wanting. It could condition myself for increased liking and even increased pursuing. But is that necessarily an addiction? Is it a chemical pharmacological addiction? So this is an important turn in this particular position paper, in that if you block dopamine, if you block the brain's ability to actually want to seek that reward, what happens? Because if there's physical addiction, you should still have physical addiction symptoms. However, the role played by such reward needs to be placed in context, such as music, humor, winning, or expecting a prize, all dopamine-mediated activities, attractive or smiling faces, a mother recognizing her child or being in love, also stimulates these same pathways. So he's pointing out, do we call those addictions? I mean, you like your mother's smile, you like good music, you like humor, but are those things addiction just because you can show that there's a context at which dopamine is mediating those responses? It might be suggested that although evolution predisposed us to like sweetness, because we need to know what food is going to give us energy, it did not prepare the body for the highly palatable foods that have been manufactured in more recent times. Have aspects of the modern diet more in common with drugs of abuse than the natural rewards that are available while the brain evolved. So now we're going to move on to something a little bit different here, activation of those individual reward circuits. So we're moving downstream a little bit from dopamine into what does dopamine do? So although addictive drugs and palatable food both increase the release of dopamine from the nucleus accumbens, it appears they influence different populations of neurons. Such a conclusion is supported by studies in which either pharmacological manipulation or selective lesions reduce the self-administration of cocaine, but do not influence the response of natural rewards. Let me move on and see what I have over here. Corelli reviewed studies that have examined electrophysical activity in the nucleus accumbens within seconds of lever pressing for cocaine, water, food reinforcement. The majority of neurons tested exhibited similar patterns of neuronal firing with, sorry, I can't see that. Oh, with both food and water. In contrast, most neurons display different patterns of firing with cocaine reinforcement. Corelli concluded that cocaine activates a neural circuit in the nucleus accumbens that is largely separate from the circuit process information about food and water. And then they did one on primates as well. So now we're looking at neurophysiology, as dopamine is exciting certain neurons from a chemical response now into providing that downstream response electrically, what's going to fire next in the brain. He said there is all of a sudden a difference that occurs in drugs of abuse versus food and water. So now we're going back to some of those early brainstem evolutionary reward-seeking patterns. So the reason that became important is because when they brought up evolution and our primal drives of reproduction, consumption, and sleep, again, the human body as just an organic entity did not know in the year 2000, 2000, or I'm sorry, 2024, 2000, whenever, 1990, whenever, these kind of things became normalized where you could become addicted to these types of chemicals, that, there would be any kind of anthropomorphic leaning toward those. So interestingly, staying true to that circuitry, food and water being a primary real drive, not something that's kind of an addition to this modern society, drugs of abuse, it just created an entirely different pathway, if that makes sense. I definitely did not explain that very well. So now looking at voltage, looking again at how we even potentiate these neurons and fire, the use of fast scan cyclic voltammetry to measure dopamine released every 100 milliseconds, blah, blah, blah. What they found is that dopamine release occurred immediately prior to consumption of cocaine, and then it was released for 1 to 2 seconds after. So that promotes more seeking, like, okay, wow, I got this. Now I want more. That's how dopamine works on your brain to keep you consuming something. Such data are consistent with an inherent difference between drugs and natural reinforcers. Natural reinforcers, again, being food, water, etc. Where these data differ, however, is that dopamine quickly returned to baseline levels after the operant response for sucrose. But there was another rise in dopamine for cocaine. So that is what creates the addictive nature. The first step toward true addictive nature is, even though your body has been satisfied with the attainment of something, dopamine keeps going. Dopamine says more, 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 more. So this is a real fork in the road looking at this neural circuitry, where as soon as your body gets a rise in hydration, if you're seeking water, or blood sugar, glucose, if you're seeking food, as soon as the hypothalamus detects that, the entire dopaminergic system downregulates. So your brain says, we don't need any more. Hunger cues go down. Dopamine-driven hunger cues go down. So why would a person keep eating? We're getting to the point in the research where we have to answer that question, because it's not being mediated by the same chemical response as you would see with an addictive drug. So let me go on before I start giving too much commentary here. Microdialysis, Fallon measured 3 neurotransmitters in 8 brain areas of rats. This was actually in a huge section. I took a very little snippet out because he went through a lot of very specific neurochemical pathways that I didn't want to get tangled up in. Fallon measured 3 neurotransmitters in 8 brain areas of rats feeding and found a pattern of change different to those associated with either nicotine or cocaine, drugs of abuse. They concluded that the reward response is highly dependent on the substance tested, demonstrating that multiple reward mechanisms operate which can encode for different stimuli. You need more than one simple measure of dopamine release to demonstrate a homology between food and drugs of abuse. So now we're going to start talking about how individuals can encode their own brains, or that can just be part of our genetics, to seek a reward response for different things. And I'll kind of bury the lead here a little bit, in that when we return back to highly savory foods that you would consider like fatty foods versus high sugar, some people binge differently on different types of foods. Some people have even neurochemical responses that are different because they individually pursue or prefer one thing over the other. That's how some people can become addicted to different things, addicted to gambling, addicted to shopping, etc. But again, air quote for that word addiction. Is it really addiction? Is it a chemical response that would require a chemical intervention? It would then show physiological withdrawal symptoms that have to be managed medically, because that's what true addiction is. Or is it just a psychological dependency, a learned habitual coping mechanism? So now let's turn to some human models, from rats to primates to higher primates. If physical addiction plays a role in the consumption of sugar, then various phenomena associated with addiction, for example, craving and tolerance, would be predicted to be observed. Most people experience food cravings at one time or another, most commonly for items high in fat or containing a mixture of fat and sugar. These from a lot of psychological models and studies on binge eating disorder and other disordered eating patterns. Fasting leads to a decline in craving and not an increase, as the addiction model predicts. Let me stop there for just a second. This was another huge clue to this type of research. If you are addicted to something chemically and you are fasting from it, either by your own will or you're somehow taken into an inpatient program or something and you can no longer get that substance, you would immediately see withdrawal symptoms. Like you want it, you crave it, you will do anything for it. When we fast from sugar, sugar cravings decrease. They don't increase. And I'm talking very acutely. That starts happening right away. So again, back to evolutionary genetics, when that food source is present, you fill up on it. That's how we maintain a better energy balance for survival. And then when you have enough, you're sated, your hypothalamus dampens down hunger cues through different mechanisms, including dopamine. Yet if you were physically, chemically addicted, the opposite would happen. You would just keep eating and not stop, and your physiological biochemistry would parallel that. And that does not happen with food. Nuance, though, we can eat ourselves into that state, even though it's not a chemical addiction. So I really like the way he summarized his position at the end. We'll get to that in a second. Um, Food cravings occur to a greater extent later in the day, while addiction model predicts, as occurring with drug use, they should occur early in the morning. Food craving, particularly for chocolate, occurs more toward the end of the menstrual cycle, whereas menstrual cycle does not influence the reaction to drugs of abuse. Exposure to sweet taste may increase food preference, although the phenomena is associated with a particular form of a particular food rather than tolerance. It is probable that we develop expectations about the taste of specific food items. That's why even visual cues or sense smells can do that. Children like intensely sweet tastes, a preference that declines during adolescence, a finding inconsistent with the development of tolerance. So that was interesting to me, in that as we get older, taste receptors, and probably because of evolutionary energy balance changes, we actually start to not be triggered the same by sugar as we do when we're younger. And yet we get our quote addictions to sugar later in life, even though that physiologically would not make sense. Hill and Prentice commented that metabolic studies show that diets high in fat are more likely to result in body fat accumulation than are diets high in carbohydrate. There is no indication that simple sugars differ from complex sugars in this regard. Epidemiological data show a clear inverse relation between intake of sugar and fat. Further, although high intake of dietary fat is positively associated with indices of obesity, high intake of sugar is negatively associated. There is ample reason to associate high-fat diets with obesity, but at present, no reason to associate high-sugar diets with obesity. So this particular section is the last part of his position paper, and I think there is a lot we need to discuss here, because this is where some of the popular authors who are very pro-ketogenic and who paint carbohydrates and sugar as just the evil, the things we should avoid. This is what's killing us. This is what's behind the obesity epidemic. If we just didn't have sugar, if we didn't have high fructose corn syrup, none of this would be happening. And every single bit of research proves the opposite. This is where if you just did a search on sugar addiction, as I started this, you would find all kinds of quote research that shows that sugar causes addiction, because they simply look at the release of dopamine. Oh, dopamine gets released, therefore it must be an addiction. That's chapter one of dopamine research 100 years ago. Does not take into context what happens next. Then they would say, oh, look, people who consume sugar, some people consume sugar, they exhibit addictive behavior. They eat more of it. They like it. They develop this taste for it. Therefore, it's an addiction. And as this particular researcher is showing, is that really addiction? Or is that just a preference? Is that habituation? Is it even chemically, as we would see with type 2 diabetes and metabolic syndrome symptoms, the fact that you are deregulating receptor sites for sugar, you're changing insulin balance and so forth. And so now your body does give you signals to eat more because you're just not efficient at using sugar. All of those things are true. Doesn't make it an actual addiction. And what's important in this turn of this paper is that it doesn't even cause obesity. I'm gonna give you a couple questions here just to make this point. How many of you, uh, if you binge, if you are somebody who says, "Man, I really struggle with sugar," how many of you have ever binged on apples? You ate an apple, and before you knew it, you were 24 apples in the tank. How many of you had half a cup of oatmeal, and all of a sudden you had consumed an entire box of Quaker Instant Oats? How many of you have ever taken a tablespoon of sugar right out of the sugar canister and you just couldn't stop? You're just all of a sudden eating all this sugar. Similarly, with fat, how many of you have ever cut all of the fat off a steak and you just eat the fat and you say, "Man, I don't even want that protein. Just give me more fat." Or how many of you have taken a stick of butter and just start mowing on the butter and then you have 6 sticks of butter? We do not get addicted, quote unquote, even behaviorally, to sugar or fat chemically. We get addicted to the combination of highly palatable foods, ultra processed, highly palatable foods. You've heard that over the last 5 to 10 years. You're going to keep hearing about it. Because if you just leave your body to its natural tendencies, those newly engineered foods that we come in contact with now all too frequently are the problem. And then if you get into even mechanistic studies, it's not even the carbs or the sugar that do the damage. It is always the fat. If you took all of the fat, all of the saturated fat, trans fat out of your cookies and your donuts and your cakes and so forth, you would be down to eating something that's just like sugar. And we typically don't keep going with that. It's that double whammy of taste receptors getting the sweet and the savory together in the kind of mouthfeel texture that we like. That's how food manufacturers engineer those foods to be so highly palatable. Um, did I just skip one here? Okay. So the World Health Organization report concluded there was convincing evidence that a high intake of energy-dense foods is associated with an increased risk of obesity, not sugar, energy-dense foods, meaning high fat. However, the sucrose or sugar content of food plays virtually no role in the determination of energy density. A lot of that has to do with the thermic effect of food. Jernowski considered the sweet tooth hypothesis that the obese find intensely sweet foods attractive. The suggestion was supported by early work, although a series of subsequent studies found no relationship or that the obese preferred actually less sweet items. Studies show that obese people actually prefer savory foods, not even sweet. A related approach is to look for individual differences and changes in preference with an increasing concentration of sucrose. Thompson distinguished a type 1 response that was an inverted U, in which preferences increased to an optimal sucrose concentration, after which they declined. So it's like, hey, this is just enough sugar. I don't want more and more and more and more sugar. After a while, it's like, man, I want less sugar. But again, the mouthfeel, the palatability of food was the driving force. Um, Most obese type 1, higher concentration sucrose were less preferred, blah, blah, blah. Studies of the effect of the sight of food, so now we're back to these visual cues, show that you do not even need to eat the food to stimulate the reward mechanism. When shown pictures of appetizing or bland food, the brain's response differed in those with a tendency to overeat. Brain areas associated with reward were more activated and the connections between brain regions were less apparent. Personality was also influential, as those who displayed a tendency for greater external eating. Um, they also concluded that those with less efficient connections between relevant brain regions may result in vulnerability to overeating. The possibility arises that pre-existing differences in the wiring of brain also predisposes people to overeating. So this brings in a couple of genetic factors, the way our brain is wired, and we know through neuroplasticity there could be some modification there. But they even bring in personality psychology here and the genetics to these things, which I hope would be of no surprise. There absolutely can be all kinds of genetic predispositions, including to our behavior and propensity to eat certain foods. That's why some people have these kind of dopaminergic reactions to high fat foods, and other people have them to high sugar foods. Um, so this final part on the obesity section is with eating disorders, specifically differentiating binge eating disorder from things like anorexia and bulimia. So the onset of binge eating disorder tends to occur in the mid-20s at a time when a preference for sweet taste has declined. Binging involves the consumption of a wide range of palatable foods, not necessarily those that are sweet. There are a wide range of risk factors for eating disorders, most of which are social and psychological rather than related to nutrition. The prediction from the rat addiction model that dieting plays a critical role in the development of binge eating disorder was not supported by literature. Opioid antagonists have a similar influence in those with binge eating disorder as to the rest of the population. There was no evidence of withdrawal symptoms. So again, I mean, all the way back to that beginning point about if this was a true chemical addiction, these opioid antagonists would work. Like Narcan would work on a binge. You're having a binge eating disorder, and all of a sudden you give yourself Narcan, and you'd be fine. Oh, shoot, I'm not eating anymore. I feel great. Doesn't happen because it's not mediated downstream the same way. Leon found that the foods eaten during a binge fell into two main groups: breads, pastries, and biscuits or cookies, and other carbohydrates, alternatively potato crisps and pretzels. So again, we're looking at kind of like sweet and savory, more whole foodish type things, breads versus snacky things. The only foods that distinguish binging from non-binging were those two types of food. Similarly, the occasional binges of non-bulimic students involved the consumption of these foods. In those with binge eating disorder, a greater percentage of energy was consumed as fat and a less percentage as protein. When the binge eating of 48 individuals with binge eating disorder were analyzed from 14-day food diaries, typically several types of food were consumed during an episode, meaning they're not binging on just one thing. For those of you who have ever binged, and I have, I would not consider myself having any type of binge eating disorder, but in dieting way too aggressively with way too much pressure for bodybuilding contests when I was a pro, I backed myself into a corner several times, particularly during one contest prep, where I was almost having out of body experiences binging, like worrying when that next binge might occur because it seemed like I had zero control. And they are exactly right that you kind of you start with one thing, a trigger type food, something that you didn't want to eat, but well, maybe just one will be okay. So you do that. And then pretty soon you're trying to stop in some way. And so you start selecting foods that are, that you hope will help you stop. Okay, I got to stop eating this. Let me just eat this, and this will help. And then let me eat this. And then you just keep going and going. And I think they are exactly right, at least in my experience, that you don't go deeper and deeper and deeper into sugar. You start reaching for more savory whole foods, both psychologically because you're looking for an exit point, but you're also looking for that nutritive value that will fill you up. And so this was just very interesting to me that in all of these studies, they had a huge chart looking at all these binge eating disorders. It was almost a meta-analysis within the meta-analysis. And it just shows that just sugar is not the thing. It's always sugar associated with fat in a highly palatable package that you can just keep eating. You can derive a ton of energy in a very quick amount of time. Given the consistent finding that opioid antagonists generally or generate withdrawal in those who are addicted, it is an obvious hypothesis that if sugar addiction occurs, then opioid antagonists should induce withdrawal symptoms. If the rat model is a homology, a similar reaction to opioid antagonists would predict as humans with binge eating disorder. And again, it doesn't. It didn't do it with cravings or addiction type behavior. It doesn't do it with binge eating disorder either. Let's see. The majority of those with a history of binging did not respond adversely to an opioid antagonist, suggesting they were not addicted. Even in rats, it is the palatability rather than sweetness that is important. And the lead found that when rats were given a choice between a high-fat and high-sucrose diet, naltrexone only inhibited the intake of the preferred diet, more often fat than sucrose. So again, it's such a clear biochemical division. So this is the thing that he wanted you to think after this entire career of work. He wanted you to the researcher to know that this is his ultimate position. And I think this is an important point for us to dive into our own discussion. The purpose of this review was not to suggest that the widespread and cheap provision of palatable foods has not played a role in the increasing incidence of obesity. Rather, it is important that the underlying mechanisms are understood so that this knowledge can generate appropriate responses. If addiction to sucrose or sugar plays an important role in the development of obesity, then various conclusions will follow. If it is falsely believed that sucrose is addictive, then inappropriate responses will be made and helpful behavior will be avoided. Stop you right there. What do we see in the low carb, anti sugar ketogenic crowd? We see an inappropriate response. Oh, sugar's the bad guy. Oh, sugar is addictive. Let's just avoid all carbs and all sugar. That creates the most eating disorders. It creates all kinds of metabolic processes that lead to worsening conditions of people. It has been shown to be the least sustainable way of eating. It has been shown to reduce metabolic capacity. It has been shown to reduce lean body mass and therefore even calcium in bones and so forth. So the absolute worst thing that we could do for our condition through food intake is the first response when you say, "Oh, sugar's the bad guy." And so he's saying, let's not throw the baby out with the bathwater. I'm not suggesting the widespread and cheap provision of palatable foods has not played a role, but if we say that's the fault of the sugar in the highly palatable food, and we're wrong, we're going to be really wrong and we're going to do damage. If we're right, then we need to continue to address it that way. Already, some have been worried that dieting may not be the best solution if it generates cravings and withdrawal symptoms. If sucrose is the villain, then attempts to deal with obesity should concentrate on this ingredient. If sucrose is not central, then inappropriately concentrating on this food will ensure that more beneficial responses will be ignored. So that was just a home run for me when it comes down to him putting forth all the evidence he did biochemically, neurophysiologically, and then saying, look, I'm not saying we don't have a problem. We have to address the problem, but sugar within these highly palatable foods is not the problem. So I'm gonna leave this open to you guys. I'm gonna pull some things up here so I can see the chat box a little bit better from my perspective. Pretty sure that doesn't change on your screen. I need to see if Dr. Souders is here yet. Yep, there she is. Dr. Souders, I'm going to let you comment first if you would like. Let's stop my share here as well.
Well, since I came in late, I can't comment on everything because I think you guys hopefully got my message that I was stuck in an appointment and I knew I was going to be late. So unfortunately, I just got here probably about 15 minutes ago, 20 minutes ago, something like that. So I can only comment on the end. What I did see was a couple of things. First, it's interesting because the sucrose hypothesis for addiction seems to be implying that endogenous opioids would be the thing that would happen as an addictive response. I mean, we talk about dopamine in the brain and things like that, but otherwise, I'm not sure why naltrexone or naloxone might necessarily work in those circumstances, because that's used for reversing an excessive opioid response in the body. And I'm not 100% sure how that really fits with, the addiction model in terms of when we're looking at it in the context of food. So I don't know. I don't know how I think about that. I'd have to go back and see the rest of the paper and maybe look up some of the references. So I'm going to decline to comment farther on that, but just putting that out there to think about it. I think that it is the bulk of the literature has made it fairly clear that the highly palatable foods are definitely the issue in most of what has been our inability to adapt to this new diet, which in terms of our evolutionary scale, the developments of technology in food science have matched kind of the developments in technology of, say, communication, internet technology. It's just such a rapid change in such a short period that we don't, we don't necessarily adapt to that. And food chemists are extremely good at doing the research and getting us to respond. So, yeah, I think that is the palatability is the issue, and it's probably mediated by something else in the brain, but I'm not sure we know what that is. And again, maybe that was stated earlier in the paper. I'm not sure. But yeah, I've always had a little bit of a problem with the true addiction theory for sucrose, for sugar, because it just compared to cocaine or fentanyl, or methamphetamine, something like that. I mean, it just really isn't quite the same. And yet there are behavioral things that are very in common. So they're very much in common. So like place, um, situation, circumstance, people, things like that. Users tend to use like if someone's going to try and become clean, so to speak. So they're going to try to treat their addiction. They may have their particular room, their particular table, their particular spot where they use. And it would not surprise me if binge eating has particular circumstances, situations, people, usually lack of people, rooms, areas, things like that. Um, so those are things. I think it's interesting that the GLP-1 products are having such an effect on this in terms of people having what's thought of as addictive behaviors, including like shopping and gambling and things like that, responding to these other hormones. So I think it's a super interesting bit of complexity going on in the brain, like what really is driving some of these non-substance related addictions. So, if we're going to postulate that sugar or, binge eating is reflective of some kind of an addictive disorder, then it may be more along the lines of a behavioral disorder with different kinds of rewards, like we would see with, say, gambling and shopping and, things like that. So, I guess I don't have any real answers, just a bunch of questions that I think it would be very interesting to, for us to consider when you're working with people in if you've got someone who has binge eating disorder, for example, um, it's nice to keep this in mind in that they may have some situational things, not just the biological things that happen. I've had those binges after competition and stuff too. I think, anybody who's lost a ton of weight, I'm sure Kevin has had that. I mean, we are human. We all do that. But what's the difference between doing it, once a year versus doing it, on a more regular basis? It's pretty fascinating.
Mhm. So as I was articulating those chemical responses to naltrexone and so forth, as I was doing that, I realized I think I was stating it backwards. So it might have been me confusing you. Dr. Benton, this particular researcher, what you missed in the beginning, is a neurochemical pharmacological researcher who also did graduate work in psychology and is a psychology professor, but brings in that behavioral professorship angle on that foundation of pharmacology. And so his entire life's work has been this kind of stuff, how food affects behavior. And some of the earlier points that we discussed were the fact that you do not see the same responses, whether you're trying to use pharmacology to increase or decrease, to potentiate or to dampen addictive type behaviors that you would expect with an opiate, a nicotine, a methamphetamine, a cocaine, that kind of thing. You don't see that at all with food. Like there's always like, yes, all of the opiates you do, like here's what physiological addiction looks like. And yet none of those neurochemical responses work when we do it with food. So that was a first break point. But to his point, and this is what I want to spend our last few minutes discussing, if we know it's not a chemical addiction, and yet he differentiates in a couple different ways, well, hedonic liking and wanting and habituated over reliance on foods, it kind of sure looks like an addiction. It feels like an addiction. No one, you included, would ever tell the difference of that versus an actual physical addiction, except for the way you probably want to address it, which he would say goes back to the behavioral side. I mean, sure, there's all the physiological stuff. You eat too much sugar, insulin receptor sites, all that. You're gonna affect glucose disposal. You're gonna make it way, way harder on yourself if you're eating high amounts of sugar and consistently, but it's still not sugar addiction. So yes, eating behavior matters, but so does your psychological assumptions of the behavior you're trying to change. If you think you are physiologically addicted and therefore it's a death sentence, I have that gene, I am addicted, you may not do the things that could help yourself, which this is now when we get into more of the behavioral 12-step type programs that actually may be more effective. So how does that change some of your thoughts there?
Yeah, that's really helpful. Makes a lot of sense. And I mean it's very clear that something like naltrexone is helpful for so many different substances. I mean, it's helpful not just for opioids, but for alcohol, for nicotine. It can be helpful um for stimulants. I mean, we're trying it with everything, and it is having a fair bit of response to those substances. So though there are these specific chemical interactions, and it just seems just even on uh, I mean, just sort of on a trite level. I mean, we need food to survive. So it's not like it's not like the use of these other substances where it's not the driving force, is more complex because I mean we have to eat, and yeah, I mean obviously we get rewards when we eat because that's that's how organisms learn, how much and what to eat. So I think that was very helpful.
Mm. And for those of you who don't know, Dr. Souders is our medical director, a physician who has also done extensive work in addiction medicine. So that's why I was so happy that you were here to see part of this. Does anybody have any questions? Anybody, clients of ours or guests who wandered in, who struggle with sugar and who may have some questions about how to reframe it and think about it and address it? Feel free to just jump in, guys. Don't have to raise hands digitally or anything like that. Kevin, since you did a little reading this week on this, which prompted me, any thoughts on your end?
No, and it's admittedly been a few weeks because I stay about 2 weeks ahead when I do these just for my own analness. But I stumbled upon it because Kevin Hall was a tagged researcher and love his work. So my skin perked or my hair perked up when I saw this and figured it was going to be good. But no, I'm really just fascinated just to learn more of what you presented, not to mention Jen's perspective. I didn't put that association with GLP and what that means. Potentially, it's really, really quite fascinating.
Well, and I think in this, we're probably too close to the end here to get into GLP-1s too far, but when I saw your research brief and I saw it was something done at the NIH, I knew Kevin Hall had to be involved, which is what made me want to even pursue this a little bit further, because I thought if that's his stance and this is a really polarizing topic, then I need to look at it a little bit more deeply. But again, you go from the entire response of even a visual cue that makes you release dopamine. Oh, that's good. I want more of that. Like that's the first hinge that we start thinking of. This is a quote addictive. But then how that dopamine travels through the entire mesolimbic system, those break points where with research, with rats, with primates, with humans, where, okay, then once you get a certain amount of glucose, you no longer want more. Like you're done. That's not addiction. A true addiction means you keep going, 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 even when you're getting the cues to stop. So in binge eating disorder, for example, you feel awful. Like you're eating to the point of pain. And now that you know that you're not necessarily doing that because it's being chemically driven, like an opiate, you have to ask yourself, why am I doing this? This is a point of the behavior that still remains unaddressed. He's just laying out the research. Okay, why am I doing this? Jen mentioned it perfectly that, well, maybe it's, I relate it to a certain context. I always do it here. I always do it in this context. It's self-soothing. It's a coping mechanism of some sort. We're either self-flagellating, like we're self-harming for some reason, or we're self-soothing for some reason. We're attempting one of those two behaviors. But now that we know it's not purely chemically driven, why? And that's where if we struggle with over consuming sugar or highly palatable foods, that's where we need to focus some time. Yes, ma'am, Dr. Souders.
Yeah, that's fascinating. Like for instance, that just prompted me, the thought about people who are cutting. They have a kind of a pain inside them that they can't cope with, and so translating that one of the theories is that the physical pain is a release point for, focusing the brain away from mental pain that they can't cope with. So there was that. The other thing I thought, though, specific to this food, and I thought was really very interesting, in the part with this when I came in at the end, the contrast between you start with sweet and it's also kind of soft, and then you go with savory and it's also kind of hard. And I wonder, it's fascinating the role of the opposing flavor profiles, but also texture profiles in it. And some of them, of course, like a hamburger is not necessarily crunchy, but it's a little bit more toothsome than, say, angel food cake or something. So I wonder how much of that is either preference or, again, the research seemed to indicate people start with soft and sweet and then they transition to like hard and savory. So is that part of the behavior that's trying to balance it out or calm it down? Or, I mean, I just don't know. There's just so much to not know here. But I think if you are a person who struggles with it, or you're working with people who, may have problems controlling their eating, maybe not on a binge eating disorder scale, but even people who just have a little bit problem, pushing away that last bit. It's great for some openings of some conversations about, how are you feeling when you just kind of, maybe you didn't quote unquote binge, but let's say you're on a diet plan and you just didn't stick to it, so what happened? There might be a lot of insight that can be learned from behavioral side of things.
We may have to do a part two in a couple weeks on just that, on the behavioral side, because I want to get into how the behavior is even impacted by the physical, such as if you are just dieting too aggressively, you're just starving yourself. You're definitely going to be more prone to overeating. And then, of course, as you said, Jen, you go to the highly, sweet foods first to get that immediate sugar response. but tons and tons to then go next into how do we address this. So we'll save that for a part 2. And anybody who has any questions here, feel free to message me, or if you're part of our network, certainly through our app, in our larger group chats. But I'm going to thank everybody for being here. Everybody who watches this on the playback later, again, huge topic, and please feel free to reach out with any questions or further help we can give you guys. And we'll see you next time in a part 2 where we can hit this a little bit deeper. Thanks, guys.